Alright, so today we're going to be solving three problems which are essentially interconnected because they are kind of the same problem. What they are the binary tree pre-order traversal, Inorder traversal, and post-order traversal. Now these three specific questions aren't important, and I mean by question 144, 94, and 145. It's just they establish the premise of how you would go about traversing through a tree. In other words, how you'd go about looking up the elements within a tree. In these three questions, they specifically ask us to return um, a list of integers, which are the actual values in the tree. So, in a way, they're asking us to return the values of the tree sorted based on the traversal pattern they asked for. In this case, it's preorder. But for the three traversal methods, there's something you need to memorize, which is the pattern. So for preorder, for example, you need to memorize root left right, and then for inorder it's left root right, and for post order it's left right root. They may seem a bit tricky maybe to memorize at first, but you can. It's really not that difficult because if you notice, it never starts with right, and right always follows left. So for example, if pre-order starts with root, then it's left, then it's right. For in order, it's left, then it's root, then it's right, because right never starts and it always follows left. And then for post order, it's left, right, root. That's how I memorized it. You can memorize it in any way you like. But yeah, so it's not really that complicated to memorize. It's just how we go about searching through elements in the tree. And if we look at this example, for example, so we have this tree. If we want to traverse it in pre-order fashion, it's root, left, right, which means what exactly? So we want to return a list of integers of the nodes of the tree sorted through the pre-order variation, and pre-order is root, left, right. Okay. So we go to this tree. The first element is 1. This is the first node we're looking at. This is the root. So we add this node to our list of integers, and then we traverse the tree on the left, which is 2. This is the next root, so add it, and then we go to the left again. This is the next root, which is 4, so we add it, then we go to the left again, which is nothing. So we go back up, and then we go back up, and 4 has already been added, 2 has already been added. So we go to the right. We traverse to the right now, because remember, it's root, left, right. So we added the root, we went to the left. We added the root, we went to the left. And then we added this root, there's no more left, so we go up, then we go to the right. Then we add this root, and then we go to the left. And then after we add this root, we go to the left, there's nothing. We go up, then we traverse the right side. And if you notice, that's the exact output. So it's 1, 2, 4, up, 5, 6, up, 7, up, 1 has already been added. Now we're traversing the right side. So 3, go left, there's nothing. We already add 3, we go to the right, 8. We add 8, then we go to the left, 9, then we go back up, and then to the right, there's nothing. And that's the output. Now for in-order traversal, it's left, root, right. And we can see that in just a moment. Okay, so since this is a binary tree problem, most binary tree problems will require us to solve them through recursion, which was what we're going to do here. And basically what recursion is when you call a function within itself, and we'll see what that looks like in just a second. But also because it's recursion, we're going to need a base case, which we'll also just look at in a second. So the first thing we're going to do is we're actually going to create the function that performs the process for us. I think I have an extra bracket here, which we'll adjust in a second. I think I just need to delete it. Yeah. Alright, so the first thing we need to do is we have to create the function itself. And we're going to make it void because we don't want it to return anything. So our function is going to be called traverse, and it's going to take a tree node, let's call it node, and a list of integer called result, And what we want are, so now it's like I mentioned earlier, we need to put the base case, and our base case here is essentially when we reach a node that's null, we want it to return and go back up. So for example, we're here at 4, node.left is pointing at null, so just return, there's nothing to do here, and go back up. So go back up to 4, and then the cycle continues. So our base case is if node is equal to null, return. That's it. So since this is pre-order, the first thing we need to do is what? We need to add the root. So we need to add 1, correct? And the way we do that is we take the list of integer and we add the node.val. Why are we adding node.val and not the val itself? That's because node carries 2 pieces of information, which is the value and the pointer to the left subtree, and the pointer to the right subtree. That's why we just want val. Val is an integer, and we need to return a list of integer, so we use .val. So we add the root value. That's done. Then what do we need to do? We need to traverse the left part of the tree, so subtree. So traverse node.left and take the list of integers called result, and then traverse node.right and return and take as input the list of integers called result. So this is where recursion is, right here. We have this function called traverse, and we're calling the traverse function within it. Remember, the function traverse takes 2 parameters: the tree node, which is the first element in our list that points to everything and has a value, and it also takes a list of integer called result. That's why we had to put both these parameters. So the code is basically done. Now we need to instantiate some variables. So we need to create a list of integer. We can call it whatever we want. Equals new array list. Then we need to call the method itself, which is traverse. And what's it going to take? It's going to take the input from the signature and the initial method, which they gave us, which is root. And it also has to take the array list we created. And we need to return the array list itself. Once we submit that, it should work, unless there is syntax error. Oh, perfect, it worked. Let's submit it. Alright, perfect. So for Inorder, if you notice, all we need to do again is change the order of the lines of code. So for Preorder, it was add, and then traverse the left, and then traverse the right. What we're doing here is we're traversing the left, then we're adding the value, and then we traverse the right side. And what that looks like is that if you have a tree like this, we're going to keep traversing all the way on the left until there's nothing, until it's null. Once we reach a stage where it's null, we can add the value before it, and then we traverse the right side. And what that looks like is, if we're starting here at 1, we're going to traverse to the left, 2, traverse to the left again, 4, traverse to the left, null, go back up, add the 4, and then we traverse all the way on the right side. In this case, it's null, so there's nothing. We just go back up, and then we go back up again. And if you notice, we just completed the entire left subtree at 2. So now we can add the 2, and then we have to traverse the entire right side. So we traverse right once, we're at 5. We go back to the initial call, which is node.left. So once we're at 5, we have to actually go and check the entire left subtree that comes after 5. In this case, it's just 6, and if we go to the left of 6, it's null. So go back up, add 6, go to the right, there's nothing. Go back up, and then go back up again. Since we've completed the left subtree at 5, we can add the 5. We can add the 5 to the list, and we can traverse to the right subtree, and then we check left, it's null. Perfect. Go back up, add 7, and then traverse to the right side, which is null. Go back up, go back up, go back up. Now we've traversed the entire left subtree of 1, and we're at a stage where we can add the value 1. and then now we can traverse the right side. We're at 3, we have to check the left subtree at 3, which is just null, go back up, add the 3, and then we traverse the right side. We're at 8, traverse the left subtree at 8, which is just 9. If you go to 9 to the left, it's null. So you add the 9, you check the right side, there's nothing, go back up, add the 8, and then there's nothing here. And that's the output you get. Yeah. And then for post order, it's almost the same again, but what changes here is we traverse the left side completely, then we traverse the right side completely, and then we add the value. So in this example, we start at 1, we traverse the entire left side, so 1, we go to 2, we go to 4. After 4, there's nothing, so go back up. Now, before we add the root, we have to check the right side. Now, in this case, it's null as well, so we go back up and then we add the 4. Then we go to the 2, but before we add the 2, we have to traverse the right subtree, so we go to 5. And once we're at 5, we have to go back to traversing the left part of the subtree. So now we're traversing the left side of 5, which is 6. At 6, you go to the left, there's nothing, you go back up to 6. But before you add the 6, you have to check the right subtree, there's nothing. Then you can add the 6. Then you go back up to the 5. But before you add the 5, you have to traverse the right subtree, which is 7. 7, there's nothing to the left. Before you add 7, you have to check the right side. There's nothing, add the right side. Now you can add the 7. You go back up to 5. Now you can add the 5. Go back up to 2. Now you can add the 2. And then here you go back to 1. But before you add the 1, you have to traverse to the right subtree. So you go to 3. At 3, you check the left subtree. There's nothing. Go back up to 3. But before you add the 3, you have to traverse the right side. So we're at 8. At 8, you have to check the left, which is 9. 9, you have to check the left, which is nothing. Then you have to check the right, which is nothing. Now you can add the 9. Go back up to 8. Check the right. There's nothing. Add the 8. Now you can add the 3. And finally, you can add the 1. So that's the pre-order, in-order, and post-order binary tree traversal problems on LeetCode. I hope you found this video helpful. Thank you for watching.